Hello people, so today we're going to be going over the quiz review, but we're only going to do the first two, like half of the problems. So let's get started with that. For this first one, if we subtract 7 sine theta from both sides, right, we're going to get 1 equals negative 2 sine theta, which means that sine theta is negative 1/2, right? So then I want you to look on your unit circle and find all theta values where sine of theta is 1/2, or negative 1/2, okay? So once you do that, you should get that theta is equal to 5 pi over 6. And also you should get that it's equal to 7 pi over 6, right guys? But then we're looking for all solutions. The key word here is all. Whenever you say all solutions, you're going to want to add something. You're going to want to add plus 2 pi n to both of these, right? Because what we're saying here is that 5 pi over 6 is a solution to this. But if we rotate 360 degrees, right, if we make a full rotation, the sine value isn't going to change, right? So we can add or subtract a full rotation as many times as we want, n times for any number n, and it will still be a valid solution. So these are our infinite family of solutions. So we have 5 pi over 6 plus 2 pi n, or 7 pi over 6 plus 2 pi n, and n can be any like whole number or negative whole number. Let's do the second one. If we do the same thing as before, subtracting 4 cosine theta from both sides, we're going to get negative 1 is equal to negative 2 cosine theta, or that cosine theta is 1/2, right? So I want you to solve on your unit circle for all of these values now. You should get theta equals pi over 6, and theta is equal to 11 pi over 6. And again, just like before, plus 2 pi n, and these are going to be our all solutions, right? Find all solutions. So I'll let you guys do these two now, but we'll move on to number 5. So solve this equation on the interval. Do not expand these terms out, right? Oh, these should all be equal to 0. That's my bad. So equals 0, equals 0. Okay, now let's work on these. So I'm just going to do the first one here because then it will be a bit obvious what to do. So if either of these are 0, then the whole term is 0. So if we have sine theta plus 1 equals 0, that means that sine theta is negative 1. And the value that corresponds to this on the unit circle from 0 to 2 pi is going to be pi over 2. Or no, excuse me, 3 pi over 2, right? And on the other hand, if we have tangent of theta plus 1 equals 0, then that means that tangent of theta is equal to negative 1. And this corresponds to 3 pi over 4 and 7 pi over 4. So we're going to put that down there. We're going to get that our solutions are theta is equal to 3 pi over 2, 3 pi over 4, and 7 pi over 4, right? Because we just looked at all the theta values that make this term 0 and all the theta values that make this term 0. And that's the only way that this whole thing could be 0, right? So next, let's solve this equation on the interval from 0 to 2 pi, right? So yeah, actually, I'll let you guys do these ones because they're pretty self-explanatory now that we've done that one. So question 8. We're going to solve cosine of 4 theta is equal to negative root 2 over 2 on the interval from 0 to 2 pi, right? So my first thing I'm going to say is if 4 theta, so we'll solve this as if 4 theta was our input, right? So what if we were just thinking about cosine of x, right? When does x make this true, right? So 4 theta can either be, if you look on your unit circle, I'll have you do that now. So 4 theta can either be 3 pi over 4, or it can be 5 pi over 4, right? So these are the two values on a unit circle that would make this true, right? So if we're doing the cosine of 3 pi over 4, then that's going to be negative root 2 over 2, and same with 5 pi over 4. You should see that on your unit circle, right? And then I'm just going to keep adding. So the thing is, we're looking for theta on the interval 0 to 2 pi, which means that 4 theta is actually going to go a little bit further, right? It's going to go from 0 all the way to 8 pi. So we need to keep adding values, right? So we're actually going to add values until each of these columns right here has 4 values in it. So because it's 4 theta, we're looking for 4 values in each column, okay? So we add 2 pi here, so add 2 pi. And 3 pi over 4 plus 2 pi is going to be 11 pi over 4. And then 5 pi over 4 plus 2 pi is going to be 13 pi over 4, right? And then you're going to add 2 pi again because we want 4 values in each column. So if we add another 2 pi, this is going to become 19 pi over 4. And this is going to become 21 pi over 4. And finally, if we add one more 2 pi to get our 4 values in each column, we're going to get 27 pi over 4 and 29 pi over 4, right? So these are our values for 4 theta. So here's row 1. But now we need to translate this into theta values. And so what we're going to do is we just divide everything by 4. So theta is either equal to 3 pi over 16, 5 pi over 16, 11 pi over 16, 13 pi over 16, 19 pi over 16, excuse me, 21 pi over 16, 27 pi over 16, or 29 pi over 16. So try the second one for yourself. So now we're going to solve this equation on the interval from 0 to 2 pi. And I will do this one with you guys because this one is a bit of a tricky one. Where is my calculator? I'll be just a sec, you guys. All right, I have found my calculator. Woohoo, I'm so prepared. So, this one has like kind of a lot of things going on with it, right? It's one of the more complicated problems. First up, you'll notice we have cosine of 2 theta here, which does not bring me joy. I'm not gonna lie. And also, you'll kind of notice that once we do this, we won't be able to factor. So let's just start out, right? So use your identity sheet to solve this into something that makes the equation easier to deal with, right? So of our options, we have, what was it? Cosine squared theta minus sine squared theta. We have 2 cosine squared theta minus 1. Or we have 1 minus sine squared theta. Which one do you choose? Because everything is dealing with cosine of theta, I don't want to deal with sine. So I'm going to get rid of these 2. And I'm going to replace it with 2 cosine squared theta minus 1, right? And then minus 11 cosine of theta plus 6 equals 0. So I'm going to distribute in here. So I'm going to get 4 cosine squared theta minus 2 minus 11 cosine of theta plus 6. And then this minus 2 plus 6 is going to be plus 4 is equal to 0. Now at this point, we can no longer factor, right? So try as you may, we will not be able to factor this. We're going to need something else. We're going to need the quadratic formula. Oh no. So if we were solving 4x squared minus 11x plus 4 equals 0, we could just use our quadratic formula and be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, right? But now with this one, we have cosine of theta in place of x. So it's actually going to be cosine of theta equals the quadratic formula. So negative b, 11, plus or minus the square root of b squared, 121, minus 4ac, so 4 times 4 times 4, which is 64, all divided by 2a, which is 8. And this is going to give you 11 over 8 plus the square root of, hold on. So it's going to give you 11 over 8 plus the square root of 57 over 8, or 11 over 8 minus the square root of 57 over 8, right? But this one is going to be greater than 1. If you plug this into your calculator, it's like 2.2 something, something, something. And so we actually are going to completely ignore this because cosine of theta can never be greater than 1, right? So we're only going to focus on 11 over 8 minus the square root of 57 over 8. So our first step is to solve for one theta value, right? So we have theta is equal to, and we can use our inverse trig functions here to get cosine inverse of 11 over 8 minus root 57 over 8. And if you plug this into your calculator, 11 over 8 minus the square root of 57 over 8, careful with your parentheses and your notion, stuff like that, we're going to get that it is, and I'm going to do this in radians, 1.125 radians. And you may be like, okay, cool, I'm done. I did the cosine inverse, we found it. But there's another value, right? So we actually have to use this special property of cosine. So if we look here, right, we know that cosine of an angle, so if theta here, it's going to be the same as cosine of negative theta. So if we went counterclockwise, that same degree measure, which means if theta is a solution, then that means that 2 pi minus theta is also a solution. So think back to like pi over 6 and 11 pi over 6, right? Or pi over 4 and 7 pi over 4. These are both 2 pi minus pi over 6 or like pi over 4 respectively, right? So what we're saying with cosine is when we have one solution, we can find another solution by just taking 2 pi minus that solution, right? So let's do that now. So we can also have, or theta is equal to 2 pi minus 1.125 radians. And if we put that in our calculator, minus 1.12, we're going to get 5.158. And these are going to be our two solutions. Yippee, right, guys? So let's look at these. Okay, we're going to solve this first triangle here. So it's your guys' favorite thing ever. It's the law of sines, right? So let's just start off. We know that sine of 22 degrees, or I'll do 49. So sine of 49 degrees divided by 32 is going to be the same as the sine of 22 degrees divided by b, right? So sine A over A is equal to sine B over B, which is equal to sine C over C. Solving for b, we get b is equal to 32 sine of 22 degrees divided by sine of 49 degrees. And let's put that in our calculator. So we have 32 sine 22 over sine 49. And make sure your calculator's in degree mode because we did the last problem in radians. So in degrees, this one was from 0 to 2 pi. So you need to be constantly switching your calculator back and forth and making sure your answers make sense. So in here, I get that the side B is 15.883. Now, we can solve for angle C actually right now because we know that the inside angles of a triangle must add to 180 degrees. So we're going to take 180 minus 49 minus 22, and we're going to get that angle C is 109 degrees. So that means that the sine of 109 degrees divided by C is equal to the sine of 49 degrees over 32. Solving for C, we get C is equal to 32 sine of 109 degrees, divided by sine of 44. So when we plug that in our calculator, so 32 sine 109 divided by sine 44, again, making sure your calculator's in degree modes, we get that C is 43.556. And voila, we've just completed this whole triangle. And it makes sense, right? So this is going to be, I'll let you guys make it make sense for yourself. I'm not going to try to do that. And I'll let you guys do the second one by your own. So this next triangle, which is totally possible now that I have edited it. Yippee, let's go. We're going to solve this triangle using the law of cosines, right? Because there's no angles that we can use the law of sines with. So I'm going to go ahead and do that. So I'm just going to pick a. So a squared is equal to b squared plus c squared minus 2bc cosine of a, right? This is on your formula sheet. And so once we do that, we can solve for a. So a is going to be the cosine inverse of a squared minus b squared minus c squared, all divided by negative 2bc, right? So if I put this in my calculator, so cosine inverse of 21 squared minus 29 squared minus 32 squared, excuse me, and we're going to divide by negative 2 times 29 times 32, okay? I'm going to get that the measure of angle A is 39.893 degrees. Okay, so now I'm going to solve for angle B. So instead of using the law of cosines again, you can totally do that. Let's actually do it both ways. So we can either have B is equal to the inverse cosine of b squared minus a squared minus c squared divided by negative 2ac. So that's going to give us, so b squared, so 29 squared minus 21 squared minus 32 squared, and then we're going to divide that result by negative 2 times 21 times 32. We're going to get 62.336 degrees. But remember, we could have also done sine of b over 29 is equal to the sine of 39.893 degrees divided by 21. And if we solve for b this way, so the sine inverse of 29 sine 39.893 degrees over 21, and we're going to put that in our calculator. So sine inverse 29 sine. We're going to get 62.336, and there we go. We just kind of verified that. So there's a lot of ways you can approach this. But once you know two angles, right? So we know this is 62.336. We're going to just be able to find the last angle by taking 180, subtracting 39.893, and subtracting 62.336. And that's going to give us 77.771 degrees. And again, I'll let you do this next one. And then our final triangle is going to be a side angle side triangle. And so first up, I'm going to set up my law of cosines. So I have, and I'm actually going to, we have to do c because we know c. So c squared is equal to a squared plus b squared minus 2ab cosine of c, right? And so c is just the square root of all of this right here, right? I'm not going to write it again. I'm actually going to do this. And if we put that in our calculator, so the square root of 23 squared plus 70 squared minus 2 times 23 times 70 cosine of 77, I'm going to get that c is equal to 68.591. 68.591. And now I'm going to use the law of sines, right? So let's solve for this little angle A here. So I know that sine of A over 23 is going to equal the sine of 77 degrees over 68.591, which means that A is the sine inverse of 23 sine 77 degrees over 68.591. And if I put this in my calculator, I'm going to get that this is 19.070 degrees. And now that I know two angles, I can solve for the rest. So 180 minus 19 point whatever minus 68 point whatever, I'm going to get 92.339 for angle B. So 92.339. And these triangles are not drawn to scale, so don't worry if it doesn't match quite well with, like, I know that it looks like angle B is greater than angle C, and it's definitely not a right angle, but I just drew the triangles arbitrarily. They're not necessarily to scale. But there we go. We just solved it. Isn't that so cool, guys? So I hope that this was helpful, and I hope that this will let you do the rest of them. Good luck, guys!